Kang, and my role was a project manager.
My name is Rita. I'm the program specialist for Team C.
Hi, my name is Xichen Liang, and my role is data analyzer in Team C.
My name is Logan Omar. I am the hardware designer, Group C.
The AEVs used within the AEV project were based upon the design by George Benny of the Benny Railplane, which was a form of transportation used to transport people in an energy efficient way through the country. It was originally meant to be implemented in 1929, but his prototype ended up not being finished and the project was dead in the water. It was our job to base this design to create our own energy efficient vehicle using whatever resources that we could find and all within reason. During the preliminary AEV designs, each group member designed their own version of the AEV. The team then compiled each one of the designs into a scoring matrix, and based upon the scoring matrix, determined which designs they were going to include in their final design. As you can see on screen, there are many different designs and many different alterations that the team came up with, and based on these designs, they got the final result shown in the images. Group C's solution to an energy-efficient AEV involved improving upon the already functional sample AEV given to the group. The group decided that the best course of action to improve the sample AEV was to add a servo brake. To implement this servo brake, the group was required to 3D print a servo wheel arm as well as a new servo brake arm, which was going to be able to grab the beam in which the AEV rested upon. The result yielded great success in terms of both stopping the AEV accurately and performance in terms of energy efficiency and time on the track.
What are the difficulties we faced throughout the AV project? At the beginning of the semester, we are having issues with teamworks, like we're not getting along each other together. But we've made it through really well at the end of the semester. And also in terms of 3D printed parts, we are having a little bit of issues like colliding issues on 3D printed parts. But we've also made it out and our AVs work well this time.
During the programming of the AEV, the team discovered that there are small discrepancies in each run within the sensors of the AEV. This was compensated by basically just making sure we had charged batteries all the time and making sure that the distance measurements that we had hard-coded into the Arduino were as precise as we could possibly get it. On top of that, the coding structure was made energy efficient through the use of the servo brake, which was used to stop the AEV instead of reversing the motors like most groups did. This led to the group being, once again, one of the top in terms of energy efficiency, and currently we had 192 joules at the end of the final run.
We are one of the top teams of the energy cost. We just cost 293 joules in total, and it's because of the 3D printing arms and our servo brake arm.
What we learned for the whole semester is we learn how to do the teamwork, and we learn how to do the Arduino programming. We also learn how to use MATLAB to analyze the data. Finally, we learned use 3D printer to print new parts. That's